People usually derive happiness from consuming products. Economists call this happiness utility. Up to a point, the more you consume, the happier you become. What's interesting is that each unit of a product does not yield the same happiness, even if the units are identical in every way. For example, suppose you've not eaten all day. You got up early, went to class, skipped lunch, and then went to work. When you finally get home, you order a pizza. The first slice of pizza gives you a large amount of utility because you're very hungry and you like pizza. The bump in your utility from this slice of pizza is called marginal utility, the marginal utility of the first slice of pizza. Marginal utility is the change in utility from consuming one more unit of a product, in this case, one more slice of pizza. Having a slice of pizza was a good idea, so you have a second slice of pizza. The second slice also gives you a large amount of utility, but not as much as the first slice gave you. The second slice of pizza gives you less utility than the first, not because it's different from the first, but because you are different. You've already had one slice of pizza, and so you aren't as hungry as you were before you had the first slice. Because you aren't as hungry, the marginal utility of the second slice of pizza is less than the marginal utility of the first slice. We call this phenomenon declining marginal utility. In general, each unit of a product you consume will generate less utility for you than the previous unit. So you continue eating pizza. The marginal utility of the third slice of pizza is less than the marginal utility of the second. The marginal utility of the fourth slice is less than the marginal utility of the third. At some point, you stop eating the pizza. You will say that you've stopped because you're full. An economist would say that you stopped because the marginal utility from one more slice is negative. Eating one more slice will actually make you worse off. Of course, you don't have a chart that tells you how much marginal utility you get from consuming things. But when you think about whether you should consume something and imagine how you would feel after consuming it, you're going through the same process you would go through if you had charts like these. So the charts don't describe how you make your choices, but they do describe what choices you make. For example, this is a ballistic trajectory equation. It tells you how far a soccer ball will travel when you kick it. This tells you what the soccer ball does, not how it does what it does. This tells you how the soccer ball does what it does. The soccer ball doesn't use the ballistic trajectory equation to move, yet it moves in the same way it would if it did use the equation. Similarly, consumers don't use marginal utility tables to make choices, but they tend to make the same choices they would if they use the table. Now, suppose you can consume more than one type of product. For example, you're in a restaurant and you can order beer and pizza by the slice. You have $16, and these are the marginal utilities you expect to get from the pizza and the beer. If you were to buy only one beer or only one slice of pizza, which would you buy? You might say that the obvious answer is to buy a slice of pizza because the first slice of pizza will add 12 to your happiness, while the first beer will only add 5. If someone else were paying for your lunch, you'd be correct, because the prices wouldn't matter. But since you're paying for yourself, prices matter a lot. When you choose what to buy, you don't look at the marginal utility, but at the marginal utility per dollar. Suppose the price of a beer is $2 and the price of a pizza is $5. At a price of $5, that first slice of pizza will add 12 to your happiness. From the first slice of pizza, you will gain 2.4 additional happiness per dollar. The first beer only adds 5 to your happiness, but since it only costs $2, you gain 2.5 additional happiness per dollar. On a happiness per dollar basis, the first beer is a better buy than the first slice of pizza. So the first thing you will buy is a beer. What will you buy next? You've already had one beer. A second beer will add 4 happiness. At a price of $2, the second beer adds 2 happiness per dollar. You haven't had any pizza yet. The first slice of pizza adds 12 happiness, or 2.4 per dollar. On a happiness per dollar basis, a first slice of pizza is a better buy than is a second beer. So the second thing you will buy is a slice of pizza. Let's walk through each of your purchases and see what we find. When you walk into the bar, you look like this. After you consume the first beer, your marginal utility for beer declines, and you look like this. After you consume the first slice of pizza, your marginal utility for pizza declines, and you look like this. So far you've spent a total of $7. What's next? You get more happiness per dollar out of another beer than you do out of another slice of pizza. So you order a second beer. Again, your marginal utility for beer declines, which leaves you looking like this. You've spent a total of $9, and you'll get more happiness per dollar from another slice of pizza than you will from another beer. So you order another slice of pizza. Finally, you consume one more beer, and you've spent your entire $16. You walk out of the bar looking like this. Now look back over your decisions. At each point you chose to consume one more of the product that gave you the greater marginal utility per dollar. But when you consumed that product, the marginal utility per dollar declined. That means that at each point in time, the marginal utilities per dollar were as close to being equal as they could be. We call this the optimal consumption combination. People consume a combination of many products such that the marginal utilities per dollar are as close to being equal as possible. Consumer choice tells us what happens when a person's unlimited desires collide with his limited resources. Almost everything you will learn in economics has its basis in consumer choice.